Hi everyone. In this video, we're going to take our graphing skills, especially our graphing line skills, into solving systems of equations. So first, we want to understand what a system of equation even is before we can jump into how you solve them. So system of equations is just like what it sounds like. So sometimes you have an equation and sometimes you have a system of them, which just means there's multiple equations to form the system. So this here is an example of a system of equations because there are two equations. There are systems with more, but we're just going to do two. Okay. And when you're looking for a system of equations, it's not that different than solving equations before. Like, let's say you had 3x equals 9. Well, you divide both sides by 3 and you get x equals 3. And when you plug 3 back in here, 3 times 3 equals 9, you get an inequality. The difference between this equation and a system is you want values that work for both equations, so they work together like a system. Now, you'll notice in these systems, we actually have two variables, right? We've got a y here and an x here, okay? So we're going to look for the y and x value that works for not just one of the equations when you plug it in, but it's going to work for both of the equations when you plug them in. And that's what our first problem here is going to look at, is here's a series of points. And hopefully we remember that a point is always written as x comma y. So this is your x value, this is your y value. Always x first, then y. Okay, and I'm asking if this is a solution to the following system of equations. Ordered pair is just a word for point. Okay, and what you're looking for is, when I plug them into the equation, plug in x for x and y for y, does it work? But not just for one equation, but for both equations. Again, just like when I had 3x equals 9 and I plugged in 3, we got a true statement. 3 times 3 is 9. That's what we're looking to happen here and here when you plug in both x and y. So let's give an example. Okay, so in problem A, just to rewrite this, x equals 2 and y equals 11. So we're going to plug in to both equations and see if it's true or if it works. Okay, so the first equation is y equals, but now y is 11. So we're going to take whatever y is and plug it in for y here. Okay, so y equals 7 times whatever x is. So now we're going to take whatever x is and plug it in for x here. So it'd be 7 times 2 minus 3. And we want to see if we get a true statement. So does 11 equal 7 times 2 minus 3? Well, 7 times 2 is 14. 14 minus 3 is 11. And you get a true statement, which means 211, as 2 is x, 11 is y, is in fact a solution to the first equation. Okay, but in order to be a solution to the system of equations, we want to make sure it's also a solution to our second equation. So we're going to do the same thing. Okay, we're plugging in 11 for y and 2 for x. So does 11 equal, well, it was x plus 3. X is now 2. So does 11 equal 2 plus 3? Or does 11 equal 5? No, it does not. So 211, although it's a solution to the top equation, is not a solution to the bottom of the equation. So when it says determine whether the ordered pair is a solution, we would say no here. Okay. In conclusion, you plug in the values, you see if you get a true statement for both. Okay. So I want you to try B on your own, and you're going to tell me whether or not 0 is a solution, or 0, 3, is a solution to the system. So just as a reminder, x is 0. So you're going to plug that in for the x values here. And your y is -3. So you'll plug those in, see if you get true statements or not. Take a moment, try it on your own, and I'll come back with the answer. Okay, here's my work. If you look below the 1, I'm calling this equation 1. If you look below the 2, I'm calling this equation 2. In the first one, it works. -3 equals -3. So 0, -3 is a solution to the first one, but it's not a solution to the second one. So no, it is not a solution to the system as a whole. Okay. We're going to try 1, 4 together one more time, where 4 is y. I'm going to go quickly on this. And 1 is x. So let's start with the first equation. Does 4 equal 4? Yes, it does. Okay. So we tested equation 1. We also got to test equation 2. So we're going to plug in 4 for y and 1 for x. And we also get 4 equals 4. So it worked for both equations this time. That means it's a solution to the whole system because it works for both. Okay, so we would say yes for that one. And I want to show you what this means visually, because sometimes I think, the calculations might make sense, but to some, the visual might make sense. So what I'm going to do real quick is, if you haven't already noticed, these are both lines in y equals mx plus b form. This will be a good review of stuff we've already done. I'm going to plot both of these lines on the coordinate plane, and I'm going to come back with that visual so we can talk about it. I suggest you practice plotting them on your own. It's good review. Here are the two lines, plotted the y-intercepts. One was at -3, one's at +3. One of my slopes was 7, so rise 7, run 1. One was +1, so rise 1, run 1. You see my slopes there. Okay, and I want to just visualize what it means that 1, 4 is a solution. Okay, where's 1, 4 on this graph? So that means x is 1 and y is 4. It's actually this point right here. Okay, so what you notice about that point is it's where the lines intersect, which means that point is on both the blue line and the pink line. And that's exactly what our solution to our system is it's which point is on both lines, which if it's on the line, it means when you plug it in, you get a true statement because that means it's on the line. So that's what you're looking for when you're solving a system is, what x and y value makes both equations true. Also translate to what x and y value combination is on both lines, as you see here. Okay, so if I plotted like 0, -3, well, we're here on the graph. And the reason that didn't work and was a no is because it's only on the pink. Okay, 2, 11 would be like way up here, and it's on neither of the lines. So it makes sense that, or it might be on lines, but it doesn't look like it's on the line. So it makes sense that that doesn't work. Okay, so now we're going to look at graphs and kind of visualize what's happening here to figure out the solution. So I'm actually going to start with this middle one here, and you want to sketch a graph on your paper that just looks something like this. It doesn't even have to be accurate. Okay, but what I want to show you is what I was talking about above. Okay, so when it says determine the solution by interpreting the graph, I'm looking for what x and y combination is on both lines. So here's one line, here's the other line. I didn't draw that well, but you get the idea. Okay, which point is on both lines? It's always the intersection point. Okay, so the solution to the middle graph here would be whatever that point is, which on the x-axis we go -1, and on the y-axis we go -1. So that would be the solution to the system by graphing. You don't have to do any calculations. Okay, but do plug in x is -1 and y is -1 into both equations, you should get a true statement. So let's say I do this, first equation, and I would get, let's see, -4 plus 3, I get -1 equals -1. And if you do the same thing in the second equation, you should also get a true statement. Okay, that's what we saw above, just to confirm. But what happens in the first graph and the third graph is a little bit different. So if you're looking for the intersection point here, what do you notice? There isn't any because these are what we call parallel lines. When you have parallel lines, and they don't intersect at all, there are no points that these lines have in common. So we would say this has no solution. Because remember, when you're solving a system, what you're looking for is what x and y value combination, aka what coordinate they have in common. Okay, and this one here, you'll notice there's only one line, but if you look at the equations, you can see why. Okay, there are actually two equations, so this is still a system, but they're exactly the same equation. So basically what you see here is one line is graphed exactly on top of the other line. So it looks like one line. So if we're solving a system and you ask yourself, what x and y combination do they have in common? You would say all points in common. Now that's a mouthful to say the solution. So we would say then if they have every point in common, and this goes on forever and ever and ever, that's why we have the arrows, we call this situation, when they're the exact same line, we have infinitely many solutions, or infinite solutions. And these are the three scenarios you could have. You can have an intersection point, which would be this coordinate pair as a solution. You can have parallel lines, would be no solution, or they could be the exact same line, and you would say infinite solutions. Okay, 3 different types of problems you will see. So now we're going to go ahead and actually try to solve. So what we're going to do is we're going to graph these lines. We're going to see what scenario we're in. Okay, so these are all in y equals mx plus b form. So before I start graphing, I just want to remember my m is in front of the x, so it's -2. My b is a number on its own. Same thing here. My m is the number in front of the x. My b is on its own. And you'll notice I'm kind of going through the graphing fast because this is a review, which is why it's so important you understand concepts from before, is because math builds on one another. Okay, but if you need more help in graphing, please let me know. For the first line, we plot our y-intercept first at -4. And then our slope is -2, which is the same as -2/1, which, as a reminder, slope is rise over run. So we're going to rise 2, run 1, but in the negative direction. You get a line that looks something like this. Okay, now I'm going to plot the other line. We'll do this in pink. My y-intercept is +3, and your slope is +1/3. So you're going to rise 1, run 3 in the positive direction. Okay, oops, that's only 2. Let's plot that over here. You get a line that looks like this. Okay, so black is line 1, pink is line 2. Again, if you need help and a refresher on graphing, please let me know. Otherwise, the point of this is to solve the system. So I'm asking what x and y point these have in common. You can say no solution, you can say infinitely many if they're exactly the same, but this one seems to, and I didn't draw this very well, but it crosses at the same point over here. So my solution then would be what point they have in common. So I'll list this as an x comma y. So this is -1 to -3 on the x, and then you go up 2 on the y. And that is the solution to the system. The graphs are the same when x is 3 and y is 2. Okay. I want you to try graphing these on your own, and I'll come back with the answer. This is going to review some old stuff. What does it look like when we have an equation like x equals 4? Right, that's not in y equals mx plus b. That's an x equals or a y equals. I'll give you a hint. It's not a diagonal line. See what you can come up with. No cheating. Okay, if graphed correctly, your graph should look like this. In the first equation, the number in front of the x is a 1 when it's not there, so your slope is 1. Okay, your y-intercept then is the other number. It's -1. So first, I plotted my y-intercept at -1. Then I went rise 1, run 1 in the positive direction, so it's increasing. That's how I got the pink line. Okay, now x equals 4. We talked about this when we talked about horizontal and vertical lines. So the rule here is that all your x values are 4. And I just picked random y values to fill in some points. I didn't pick any, for any good reason, but I plotted 4, 0, then 4, 1, 4, 5, 4, -3. Connect the dots, you can see it's vertical. It's a good strategy. Quick review of some old stuff, just threw it in there for you. And we notice that they intersect here, so back to the main point, that must be the solution to your system. Okay, again, if they were parallel, there'd be no solution because they never touch. And if they plotted on top of each other, so say it's like this line, then this line, and they were exactly the same, that would be infinite solution. But we had an intersection here, so let's figure out what that point is. On the x-axis, you move to 4. On the y-axis, you're at 3, which actually makes sense because the equation was x has to equal 4, so the x value of the intersection has to be 4. Okay, but that's how you solve a system, by graphing. There are other algebraic ways to do it, but I find that it's good to start with a visual. So in conclusion, when you are solving a system, you're asking yourself what x and y points do 2 equations, aka a system of equations, have in common. And when we talk about x and y, we usually write them as a point, x comma y. If you have any questions or need help remembering how to graph lines, please let me know. Otherwise, have a good night.